ఆల్కేన్ ట్రీటెడ్ విత్ KMnO4. సో జనరల్గా మనకి ఆల్కేన్తో నో రియాక్షన్, బట్ అకార్డింగ్ టు ఎన్సీఆర్టీ కోల్డ్ కండిషన్లో మనకి టెర్షరీ హైడ్రోజన్, సో టెర్షరీ హైడ్రోజన్ ఉంటే, సో టెర్షరీ హైడ్రోజన్ ఉన్న కాంపౌండ్కి KMnO4 యాడ్ చేస్తే మనకి టెర్షరీ కార్బన్ దగ్గర సింపుల్గా ఆక్సిడేషన్ జరిగి కరస్పాండింగ్ టెర్షరీ ఆల్కహాల్ ఫామ్ అవుతుంది. ఇట్ ఈస్ సింప్లీ ఆక్సిడేషన్ only at tertiary carbon. Now it is treated with Al2O3. So alcohol treated with Al2O3. Low temperature ether form అవుద్ది, high temperature alkene ఫామ్ అవుద్ది. లో టెంపరేచర్ ఈథర్ ఫామ్ అవుద్ది, హై టెంపరేచర్ ఆల్కిన్ ఫామ్ అవుద్ది. సో లో టెంపరేచర్లో ఇక్కడ క్వశ్చన్లో మనకి హీట్ ఇచ్చారు, హీట్ అనేది మెన్షన్ చేశారు. హీట్ మెన్షన్ చేశారు కాబట్టి ఎలిమినేషన్ జరిగింది. ఎలిమినేషన్, దట్ మీన్స్ ఇన్ దిస్ కేస్ డీహైడ్రేషన్. దట్ మీన్స్ ఇన్ దిస్ కేస్ డీహైడ్రేషన్. It is a alpha carbon, it is a beta carbon, it is a beta carbon. Therefore we get two types of alcohol, one alkene like this and another alkene like this. So you get two alkenes, and among these two it is a stable alkene. It is a stable alkene, therefore it is a major product. The reactant is epoxide. To epoxide we are adding lithium aluminum hydride. H minus is nucleophile, it is a hydride. H minus is nucleophile, and when H minus attack on the epoxide, it follows SN2 reaction. And for SN2 we know that general order primary greater than secondary greater than tertiary. It is a general SN2 reaction order. Therefore it is a secondary carbon, it is a primary carbon. H minus attack at this carbon, ring opening takes place. Therefore the structure of A, you can write this is a O minus above the plane and hydrogen, and this hydrogen coming from the LiAlH4. Now it is treated with acidification. Acidification means we are adding H plus to neutralize O minus. O minus take the proton and corresponding alcohol is formed. Corresponding alcohol is formed. So it is not chiral center. It is not chiral center. Therefore you can write simply without stereochemistry we can write. Without stereochemistry we can write. It is the first compound. Now second one is alcohol treated with PCl5. So we know that when alcohol treated with PCl5 through SN2 mechanism, we get corresponding alkyl chloride, POCl3 and HCl. Therefore here through SN2 mechanism, in place of OH we get corresponding alkyl chloride. We get corresponding alkyl chloride, and the side products are POCl3 and HCl. It is also nucleophilic substitution. Here the reactant is alkene, and we are adding electrophile. So this entire reagent is oxymercuration demercuration. This entire reagent is oxymercuration and demercuration. So when alkene treated with mercury compound, when alkene treated with mercury compound, so alkene attack on the mercury, leaving group will leave. It forms corresponding stable C. It forms corresponding 3-membered ring. Of course above the plane and below the plane. Now it reacts with nucleophile H2O. It is a primary carbon, it is a secondary carbon. Nucleophile attack at secondary carbon, ring opening takes place. So this overall reaction is electrophilic addition. This overall reaction is electrophilic addition. Now it is treated with NaBH4 through free radical substitution. In place of mercury, we write simply hydrogen. In place of mercury, we write simply hydrogen. So this is a oxymercuration, demercuration. Now it is treated with SOCl2. This compound name is thionyl chloride. This compound name is thionyl chloride. When alcohol treated with SOCl2, so we know the basic reaction. When alcohol treated with the SOCl2, it follow SNI kinetics and gives corresponding alkyl chloride, and we know that SNI mechanism follow retention in configuration. So similarly here, alcohol group is there and SOCl2, therefore corresponding product is corresponding alkyl chloride, SO2 plus HCl. So to convert alcohol to alkyl chloride, suppose HCl, PCl3, PCl5, SOCl2. We can use 4 reagents, but among these four, SOCl2 is best because one of the product is gaseous product SO2 and which releases from the container. As a result, reaction will be completed. Alkene treated with B2H6. When alkene treated with B2H6, this reaction is known as hydroboration. In hydroboration, more sterically hindered carbon, hydrogen, should be connected, and less sterically hindered carbon, boron, should be connected. Here we are connecting hydrogen and here we are connecting boron. This is hydroboration. Now it is treated with H2O2 and OH minus. Now here H2O2 react with the corresponding boron and finally we get OH group in place of boron. This is known as oxidation. And the overall reaction, syn addition. That means both hydrogen and OH will be attached from the same side. It is a primary alcohol. Now the alcohol treated with PbR3. So we know that the basic reaction, when alcohol treated with the PbR3, SN2 reaction takes place. In place of OH, we write simply alkyl bromide and PbR3 will be converted to H3PO3. So this is a basic reaction. So similarly here, it is a primary carbon. We are adding PbR3, SN2 reaction takes place and the corresponding product is, in place of OH, we can write Br and PbR3 will be converted to H3PO3. It is a ketone treated with H2PD. When ketone treated with H2PD, this reaction is catalytic hydrogenation. So in catalytic hydrogenation, so H2 will approach the ketone from the above the plane, from the below the plane. Therefore, we get corresponding products. OH above the plane. Suppose hydrogen attacks from the below the plane. Now OH below the plane. Suppose hydrogen attached from the above the plane. So this is a catalytic hydrogenation. Now these compounds treated with HCl and ZnCl2. The general reaction is, when alcohol treated with the HCl and ZnCl2, secondary and tertiary follow SN1 mechanism Primary either SN2 or no reaction at room temperature. No reaction at room temperature. Therefore, corresponding product is alkyl chloride. So it is a general reaction which was discussed in the class. Similarly, here it is a secondary alcohol. It is also secondary alcohol. When secondary alcohol we are adding H plus, both molecules loses carbocation H2O, and finally they give corresponding carbocation. Both compounds will give the same carbocation. Losing the H2O molecule, losing the H2O molecule. Now of course here migration possible. Now we got carbocation planar. Now it react with the Cl minus attack on the corresponding carbocation, and it is a final compound. It is our final compound, alkyl chloride. So it is insoluble in Lucas reagent. Insoluble in Lucas reagent. So finally there is no stereochemistry because there is no chiral center. That's why I have written the molecule in a simple way without stereochemistry, without 3D. Neopentyl bromide. This molecule name is neo. 4-degree carbon is neo. Total 5 carbons. Neopentyl bromide. When neopentyl bromide treated with moist AgNO3, it's not AgNO3, slightly printed mistake, it is Ag2O. Moist Ag2O. So moist Ag2O means we should think simply AgOH. So in the presence of Ag plus, it loses Br minus and forms stable C plus. Even though it is primary, it forms stable C plus because of Ag plus and another supporting factor because of strong plus sign nature. Now once a C plus is formed, we have to consider migration. From here migration happened. Now it reacts with OH minus and corresponding alcohol will be formed. It is a tertiary alcohol. Now the tertiary alcohol treated with the copper heat, temperature generally 300 degrees Celsius. Copper heat 300 degrees Celsius. Suppose primary alcohol treated with the copper, it gives aldehyde. Secondary alcohol, if you treat with the copper, secondary alcohol treated with the copper gives ketone. Tertiary alcohol with copper, dehydration takes place. So tertiary alcohol ki dehydration possibility. Therefore in this case it is alpha carbon, beta carbon, beta carbon. So we expect two alkenes, one alkene like this and another alkene like this. So two alkenes are forming, and among these two it is a stable alkene. Therefore corresponding product is major. Alkene treated with cold alkaline KMnO4. Cold alkaline KMnO4. It is a Bayer's reagent. It is a Bayer's reagent. So Bayer's reagent treated with the alkene. Suppose it is a simple alkene. Now it is treated with the Bayer's reagent, and the simple answer is corresponding 1,2 dihydroxyalkane. So it is also called vicinal diol. Vicinal diol, also known as penacol. Also known as penacol. And in the presence of Bayer's reagent, this reaction is syn hydroxylation. This reaction is syn hydroxylation. Therefore here it is a double bond, and which is trans isomer. Which is trans isomer. And we know that trans isomer anti-addition meso or trans addition anti-addition, trans isomer anti-addition erythro. Trans addition syn, trans compound syn addition racemic, simple racemic, or trans compound syn addition threorasmic. So here we should write threorasmic. So threo means how to write the answer? Here CH3 and here pH. CH3 group and benzene group. Now here CH3 and pH. Okay. Now erythro and threo. Erythro means the same side, threo means opposite. So it is a trans compound. It is a syn addition. Therefore we get corresponding threorasmic mixture. We get corresponding threorasmic mixture. So here simply threo means both OH groups are opposite side. Both OH groups are opposite side. And the remaining groups here hydrogen, hydrogen, two hydrogens. So it is our final product. So we get corresponding threorasmic mixture. Now this mixture treated with MnO2. This mixture treated with MnO2, and we know that MnO2 oxidizes only allylic alcohols or benzylic alcohols. MnO2 oxidizes only allylic and benzylic alcohols. Now here this part is benzylic alcohol part and this part is benzylic alcohol part. Therefore we get corresponding product CH3 hydrogen OH C double bond O pH. Next compound CH3 OH hydrogen C double bond O pH. So here it is a oxidized part. It is a oxidized part. And this overall mixture is again it is a one chiral center, it is another chiral center, and the overall solution is again racemic mixture. Racemic mixture. So the final answer is these two compounds. The reactant has two functional groups. One is ketone, one is carboxylic acid. When it is treated with one equivalent of B2H6 with acetic acid presence, so here one functional group is ketone, another function is carboxylic acid, and we know that B2H6 is highly reactive for carboxylic acid. B2H6 is highly reactive, highly selective for carboxylic acid. Therefore here ketone reduction should not be considered. Only acid will be reduced to primary alcohol. Carboxylic acid will be converted to primary alcohol. Now this product is treated with NaBH4. NaBH4. And definitely NaBH4 do not reduce alcohols, but NaBH4 sodium borohydrate attack on the ketone, pi bond will be shifted, therefore nucleophilic addition, and the final product is O minus and CH2OH. And after acidification, if acidification is not given, granted we can take OH and CH2OH. And we know that NaBH4 do not reduce acid, ester, amide, cyanide, nitro, and epoxide. So these functional groups cannot be reduced by NaBH4. Cyclic ester, it is also called lactone. Cyclic ester also known as lactone. When lactone treated with LiAlH4, lithium aluminum hydride, so from this we get H minus. So H minus attack, leaving group will leave, and finally it gives corresponding aldehyde. Now this aldehyde again react with H minus, pi bond shifted, and corresponding product is O minus and O minus. and after acidification the corresponding products are OH and OH. So this is a carboxylic ester reduction with lithium aluminum hydride. Now it is treated with excess of PCl5. It is a primary alcohol. It is a primary alcohol. When alcohol treated with PCl5 through SN2 mechanism, in place of OH, we should write chlorine, alkyl chloride, and POCl3 plus HCl. So these are the reactants and products. Now similarly here excess we are taking, therefore primary alcohol, and the corresponding product is chlorine and chlorine dichloro compound. So it forms through SN2 mechanism. It is a carboxylic ester. When carboxylic ester treated with lithium aluminum hydride, so it is a carboxylic ester treated with the lithium aluminum hydride H minus. So H minus attack, leaving group will leave. Therefore we get corresponding CH3 C double bond OH, and the leaving group is CH3 CH2 O minus. Again it react with another H minus because it is aldehyde. So H minus react, pi bond shifted, and corresponding product is CH3 CH2 O minus. So here we are having 1 mole of CH3 CH2 O minus, another mole of CH3 CH2 O minus. Now if I consider acidification granted, I will get corresponding alcohol. Now this alcohol treated with BF3 and CH2N2. So in the presence of BF3, here CH2 minus take the proton from the alcohol in the presence of BF3. It gives finally CH3 CH2O minus and CH3N2 plus. So CH2N2 is diazomethane. So with diazomethane, acid base reaction takes place. Now it undergo SN2 type of reaction, and finally it gives corresponding methoxy product, and the leaving group is N2. It is purely SN2 reaction because it is a strong nucleophile and it is a primary. Strong nucleophile and primary SN2 reaction takes place. Finally we got corresponding propane and N2 gas.